yield. We'll go over that in just a second, but we're going to get started with a quick warm-up problem with Stoich because, like I said, Stoich will never end. And if you still don't get Stoich, I'll see you guys next year, okay? All right, so let's get started. So I got the equation for you. I got it balanced. I got you the molar masses. So if you guys feel confident setting it up on your own, you can ignore me for a little bit and do that. But if you don't know how to do Stoich, make sure that you guys are following along, okay? Okay, so in this problem, it's asking us how many grams of gaseous products we're going to be making, okay? So if you guys look at the term product, products are chemicals on the right side of the arrow. The left side, those are called the reactants. Chemicals on the right side are the products, okay? So between the two chemicals on the right side, which one of these is the gas? Yes, CO2, and we know that because it has a G next to it. So in this problem, what we are looking for is going to be CO2. This is what we are looking for. Okay, so far so good, guys? Okay, and it's asking us how much CO2 is going to be made from 15 grams of CH4 excess O2. So excess means you have so much, you don't need to worry about it. So we can just ignore the O2. Okay, which means that our starting number is going to be 15 grams of CH4. So we start with CH4, and then we're going to be finding CO2. Okay? So from here, it should be basically the same thing we've been doing. I'm going to set up my stoichiometry. We got 15 grams of CH4. You're going to set up your 3 fractions. And then on the tops, we're just going to put gamamaga. Okay, so like I've been saying, we're not doing anything new basically for the entire year. We're going to keep doing stoichiometry. We're just going to be adding new things to stoichiometry. Okay, so we're going to write 15 grams of CH4, set up our 3 fractions. The tops are going to be gamamaga. Okay. Any questions about that? Y'all chilling? Okay. Okay, so before we move on, let's write some new information or write some more information that'll help us with the setup. We know the first 2 fractions are always about the same chemical. So we're going to write CH4 on top of the first fraction. Okay. The first 2 fractions are always about the same chemical. That's why we're going to put CH4 on the top right here. Okay. The last 2 are also going to be about the same chemical. And since we're looking for CO2, we're going to put CO2 on the last 2 fractions. Okay. Okay, so for a lot of you guys, it's going to be a review, just regular Stoich. God bless you. Okay. For the first fraction, the numbers are going to come from the molar mass. The second fraction, the numbers come from the balanced equation. And the last fraction, the numbers come from the molar mass. Okay, so if you guys don't know that, this is your little review of stoichiometry. Okay, but if you guys know this, you guys don't need to copy down the stuff on the bottom. Okay, let's start plugging things in. I want to get rid of grams of CH4, so I'm going to put grams of CH4 on the bottom right here. Okay, we get the numbers from the molar mass. What's the molar mass of CH4? 16. So 16 is next to grams. So I'm going to put 16 on the bottom and 1 on the top. That lets me cancel out the grams, and we're done with the first fraction. Yes. Huh? I am. No, it's all molar mass is always 1 mole. Yeah, by definition, it's 1 mole. Good question, though. Okay. On the bottom right here, we're going to put what we have on the top. So moles of CH4. So we're going to put moles of CH4 on the bottom. We get the numbers from the balanced equation. So let's look at CH4. What number is in front of CH4? 1. Yeah, if it's nothing, it's 1. So we put a 1 on the bottom. What number is in front of, not that one, CO2? Yeah, 1. There's nothing there. So from there, we can cancel out the moles of CH4. And then lastly, we're going to put moles of CO2 on the bottom. And then if you look right here, CO2 is 44 grams. We got to put it next to grams. So 44 grams divided by 1 mole. And there you go. That is going to be your setup for this stoichiometry problem, okay? So I'm just gonna be straight with y'all. This should be super easy. You should be able to set this up without my help at this point in the class. But if not, if you did need the help and it was difficult, please make sure to keep reviewing and practicing Stoic, because you're just kind of falling further and further and further behind. And as much as I love everybody, I don't want to see you next year, okay? So make sure you learn this so you can get out of here at June. Okay, let's plug this into the calculator and we'll be all done. So for the calculations, we want to multiply everything on top, divide everything on the bottom. Our first number is 15. We're going to divide that by 16. Skip all the ones, and then we're going to multiply that by 44. And that's going to give us our final answer. So I'm going to punch that into my calculator. 15 divided by 16 times 44. And we'll get a final answer of 41.25. And it's going to be grams of CO2. Okay, so 41.25 grams of CO2. Okay, so hopefully not too bad. That's kind of what I'm expecting you guys to know as we start Unit 5 now. So this is the review. Now we're going to jump into Unit 5. Okay, so I want you guys to look at this number. Make sure you have this written down. Hopefully you have this in your notes, because we're going to add one vocab term right now. So this number right here is what we call the theoretical yield. Okay, make sure you guys write this down. This is called the theoretical yield. Theoretical yield. Okay, because this is what we yield, what we make in theory. Okay, this is what we should make. So that's why the lecture today is called theoretical yield, actual yield, and percent yield, because you can theoretically make something, right? Theoretically, everyone here is going to get an A, right? Or can get an A. But the actual reality is that some of you guys are going to get A's, okay? And so that's the same thing with chemistry. You can theoretically make a certain amount. Here, we should theoretically make 41.25 grams. But in actuality, in reality, that doesn't always happen. And so that's what we're going to be talking about today, okay? So let's go on to the definitions. So theoretical yield, we already wrote this, so don't write this down. Theoretical yield, but I do want you to write this down, is what we should make in a reaction, and it comes from your calculations. It comes from your stoichiometry. So whatever number you get from your stoichiometry is called the theoretical yield. Make sure you write that down, because I think that's the easiest way to remember it. Your theoretical yield always comes from your calculations. Your stoichiometry tells you how much you should make. Okay. So that's theoretical yield, how much you should make. Okay, that's different from this right here. And make sure you write this down, the actual yield. And actual yield is how much you actually make, right? That's why the name is actual yield. And you get it from your lab. So if you guys notice, in the labs we've been doing, we take compounds, we react them, and we make a certain amount, and we weigh it at the end. You guys might have noticed it's going to be off sometimes, right? Sometimes by a lot, sometimes a little. So there's a difference between what's actually made in the lab and what you should theoretically make based on your calculations. So that's the difference between the two, okay? Theoretical yield comes from your math. Actual yield comes from your lab. Whose headphones is that? Somebody's headphones really loud. I'm scared for your ears, for sure. Just turn it down a little bit. Can't be going deaf. You guys can barely hear me already. Okay, so theoretical and actual. Any questions about the definitions? Okay, so you guys don't need to write the next parts down, but I'm going to talk about why it's important for us to understand this. And it's because chemical reactions that people run are not 100% efficient. You guys probably noticed that. You guys aren't 100% efficient. Okay, so no matter what, you usually can't make the theoretical yield. And you guys might have seen why during the labs. Okay, you guys might notice sometimes stuff just gets stuck to the glassware, right? Again, don't write this down. Like when you guys are poking stuff with the stirring rod, some of you guys are asking me, Why is it okay if it sticks to the stirring rod, right? Sometimes you spill during transport, right? And other times, just chemically, it doesn't always go to completion, okay? So the key thing that you guys want to write down is that your theoretical yield, I'm going to just write TY just because it's a lot faster. It's not thank you. Your TY will 99.9999999% of the time, it will be less than your actual yield. Okay, you will almost always make a lot less than you should. So your actual yield, oh wait, sorry, I messed this up. It's the other way. Your theoretical yield will be greater than the actual yield. Sorry about that, guys. Okay, so the number you get from your calculations should be bigger than the number you get from the lab. Okay, and companies that make chemicals and medicines, they spend billions of dollars trying to increase their actual yield by like 0.1%, 0.2%, because if they can do that, you know, remember, they're making giant amounts of chemicals at one time. Okay, 0.1% increase in efficiency could be tons and tons of that compound they're trying to make. So increasing the actual yield is something that people spend a lot of money trying to increase. Okay, but sometimes in your lab, especially since we're not perfect here, your actual yield might be greater, okay? And if your actual yield is greater, and I want you guys to write this down, if your actual yield is greater, there's 3 reasons why that could happen. Number 1, and this is the most likely one, your product is most likely impure. You don't have what you think you have. Okay, you don't have exactly what you have in there. You could say, I made this chemical, but there's probably some other stuff in there. Okay, that's one way the mass can be greater than the theoretical yield. Okay. Okay, so if you guys remember last time or the last unit, we talked about which reaction happens. Sometimes a reaction that you thought was going to happen didn't happen. And that's one reason why the actual yield might be greater. Okay. Another big reason is just insufficient drying. There just might be some water in there, and so you didn't dry out all the water. And then last thing, you might have some contaminants or different chemicals that got added in somehow. So for example, let's just be honest, you guys aren't that great at cleaning the glassware, and people from other periods are not that great at cleaning glassware. So there's probably some other stuff in there, right? It's not clean when you guys first get it, and so that might contaminate your product, okay? So those are some ways, so those are some reasons why the actual yield might be greater. So when we're doing our labs for this unit, we're gonna be calculating theoretical yield, we're gonna be making chemicals, that's our actual yield. And if your actual yield is bigger, these are probably the most likely reasons why. The other reason that I didn't write was you messed up on your math, but I'm going to assume that you guys didn't mess up on your math. All right, and the last thing I need you guys to write down before we go into our final practice problem is this right here. So we talked about the theoretical yield, we talked about the actual yield. Now we use those numbers to talk about something called the percent yield just because we like thinking about things in terms of percentages, right? 50% is a lot easier than talking about how 0.243 grams of something is half of the actual yield, right? So we like to talk about percentages, and this is the formula for the percent yield. It's going to be the actual yield divided by the theoretical yield times 100%. Okay, so on your assignment today, and I'm just going to let you guys know there's a lot of Stoic, you're going to have to find the percent yield. This is how you find percent yield. You divide the actual yield by the theoretical yield, and then you multiply it by 100. Okay. All righty. Before we do the last problem, any questions? Y'all chilling? Okay. All right. So I did have a problem on here that I was going to go over, but I saw Mr. Edwards today, and that made me feel like a better person. And so I'm actually going to do the first problem on your assignment for you guys. And so you guys will get the answer to the first problem. Okay, so can everybody look at Mr. Edwards and say, thank you. Thank you. Thank you, Mr. Edwards. Did you guys know we're rush hour? Mr. Edwards and I are rush hour. Yeah. Do you know which one? Do you know which member of rush hour I am? Do you, hey, Jordan, which one do I look like? I'm obviously Chris Tucker, right? I'm obviously Chris Tucker. And he is Jackie Chan. Dude, you guys need to see Mr. Edwards fight. That man's a beast. Okay, just like Jackie Chan. Okay. All right, so if you guys want to pull out a piece of paper, the one that you're going to do for your assignment, please do that, because I'm going to do number 1 for you. Well, I mean, you guys can do it with me, but we're going to do number 1. So I'll give you a minute to pull out your piece of paper. Come on, Jordan, why are you profiling me? I am clearly Chris Tucker. You should not be talking about being racist. You should not be talking about being racist. Guys, this lecture is being recorded. Can you watch it on the race stuff? You're not. Nobody here is racist. You guys just like using that word. You guys, it's like your favorite word. Nobody, hey, whoever's listening to this video, nobody here is racist. They just like that word for some reason. That's weird. Alrighty, let's get started with number 1, okay? So first thing I'm gonna need you guys to do is I'm gonna need you guys to write the balanced equation. I'm gonna balance it for you. Okay, 4, 2, copy this down on your paper, number 1. Yeah. Okay, so you guys should be copying down the balanced equation. Okay, so you guys should all be copying down this equation. You're gonna have to turn this in for your assignment anyway, so I'm just basically doing one of the problems for you. Yeah. It's great. Yeah. Definitely don't think it's because of you guys. You know what, bro? Let's think right now. You know what he said? He said it's most definitely not this way. Yeah, definitely not. You guys should know that by now. Sure. Okay, let's move. Okay, you guys should have written down the reaction. Let's move on. So it's telling us that 15 grams of Ag2S reacts with excess CN. If I have excess of something, that means I don't need to worry about it, right? I have so much. So we can ignore the KCN. Okay. And then it's asking us to determine the theoretical yield, the actual yield, and the percent yield if it produces 5 grams of K2S5. Okay, so when we do these problems, I'm going to give you guys one of the answers just right off the bat. Okay, so you guys can just write somewhere on your paper that the actual yield is equal to 5 grams of K2S. There you go. That's one of your answers. Okay, and usually when we do this in the lab, I'm not going to give you the numbers, but the number that you guys get in your lab that you weigh out, that's what the actual yield is. Okay, but since we're not doing a lab yet, we're going to be doing it next week. I'm just going to give you the actual yield. Okay, so the number that's given right here, if the reaction produced 5 grams, that's the actual yield. Okay, so we're done with one of them already. Okay, all right. In order to find percent yield, we need to find theoretical yield. So let's do theoretical yield. That's going to be our stoichiometry. So our starting number, it looks like it's 15 grams of Ag2S. So 15 grams of Ag2S. And then from here, it's the same thing as normal. So if you guys are confident in your story, you guys can kind of ignore me for a little bit and solve this out on your own. Okay, but I'm going to go through it step by step. All right, the tops, we're going to put gamumaga, so grams, moles, moles, grams. And then since we're looking for K2S, we're going to put K2S on the last two fractions because remember the last two fractions need to be about the same chemical and the first two fractions are about the same chemical. So we're going to start with Ag2S and we're going to end with K2S. So again, nothing's changed in terms of the stoichiometry. For the rest of the year, the core of everything that we do is going to be this three-step fraction stoichiometry stuff, okay? So please learn it because it's really annoying to grade your papers when like this is wrong. Yeah. Yeah, no, good question. So the reason why we're using K2S is because it's asking us to find the theoretical, actual, and percent yield for 5 grams of K2S. The 5 grams is the actual yield, but it's for K2S, right? So whatever number that I give you, whatever chemical you find for the actual yield, that's the one you want to compare the theoretical yield to. Does that make sense? That's basically just what we're looking for. Yeah. I mean, you could find the theoretical yield for the other guy, but in this problem, you don't have the actual yield, so you can't find the percent yield. And so that's why we're finding for K2S. That makes sense? It's a good question. Okay, let's plug in our numbers. So for this problem right here, or this fraction, we're going to get the numbers from the molar mass. So we're going to put grams of Ag2S on the bottom, and I'll give you the molar mass. It's going to be 247.8 grams per 1 mole. And you'll get this number from the periodic table. Why are you guys touching each other? Okay. For the record, whoever's listening to this video, we got 2 dudes in period 5 touching each other's shoulders. And you know, I'm not gonna judge, but there's a time and a place for everything, and this is not the place for it. And one of them, and they're both smiling too. All right, moving on. Okay, we're gonna put moles of Ag2S on the bottom. You've been done smiling, okay? And then we're gonna get the numbers from the balanced equation. Hey, but no shame, dude. There's nothing wrong with 2 bros. Well, I don't know. You seem to be liking it. Okay, we can get it from the balanced equation. The number in front of Ag2S is gonna be 1, right? So we put a 1 on the bottom, and then we're gonna put a 1 on the top because the number in front of K2S is also 1. Okay. So 1 on the top, 1 on the bottom. All right, and then we're going to put moles of K2S on the bottom, and we're going to get the numbers from the molar mass. And then I'll give this to you as well, but it's going to be 110.26 over 1 mole. All right, so I'm going to give you guys 30 seconds. I want you guys to calculate the theoretical yield using your calculators. And then if you think you can find the percent yield, please go ahead and do that as well. Okay? Yeah. Dude, I'm gonna go over in like 30 seconds. Yeah, you can wait. Hey, patience is a virtue, okay? 100 on your calculator. What? Not like that. Not like you guys, weirdos. Hey, there's nothing wrong with 2 bros showing a little skinship, as long as it's not weird. But you guys are the weird ones doing it in the classroom. Yeah. I don't know. No, but I don't do it in class. There's a time and a place. What you hear about me? Well, you already knew that. Alrighty, shh. Let's bring it back together. Okay, let's go over the answer for this problem. So we're gonna plug it into the calculator. So our starting number is 15. We're gonna divide it by 247.8. We're going to multiply it by 110.26, and we'll get a final answer of 6.674. So 6.674 grams of K2S, and this is going to be our theoretical yield. Okay, so there we go. We got the theoretical yield and the actual yield now. I have. All right, and then last but not least, we are going to finish up with the percent yield. So we're going to be using the percent yield formula. And so what we're going to do is we're going to go, hold on, let me make a little bit more space right here. Okay, so what we're going to do is we're going to plug this into the percent yield formula. So for percent yield, we know that percent yield is equal to the actual yield divided by the theoretical yield times 100%. Hey, shh. Okay, so we're going to plug in our numbers. What's our actual yield for this problem? Yeah, 5. What's our theoretical yield? Yeah, 6.674. And then we're going to multiply that by 100%. Okay, so our final answer for this problem is going to be 5 divided by 6.674. Hey guys, be quiet. 6.674. And then we're going to multiply that by 100. And there you go. So your theoretical yield or your percent yield is going to be 74.918%. If you got something close to that, that's fine. If you got like 74.917, 74.92, 74.91, as long as it's close to that, you chill. Okay?
Mr. O,
Yes. You can. There's rounding rules that I mentioned a long time ago. If you know them, you can, but if you don't, just be safe and just put all the numbers. Yeah, good question. Alrighty, guys, I'm gonna give you guys the rest of the class period to work on your assignment. It is kind of long, so make sure you guys are using your time wisely. If you have any questions or if you want to check your answers, please let me know. But good luck on your assignment, guys.